In this video, I'm going to show you how to identify an acid or a base once it's inside of a chemical reaction. So what I like to do is call this the bouncing hydrogen rule. So what we're going to do is we're going to look at a chemical reaction and we're going to find the hydrogen and we're going to watch how it moves from left to right in the chemical reaction. So here's a chemical reaction. Write this down. Now, acids and bases can only appear on the left-hand side in a chemical reaction. So we're always looking for the acid or base on the reactant side. The reactants are always on the left. So we've got two compounds here, HCl and NH3, both which contain a hydrogen. It doesn't matter which one you start with. I'm going to start with the HCl because it comes first. So I look at the H that's in the HCl. And I say, okay, well, where'd this H go? Well, if I look at it, I can see that it went to the NH3. Now, how do I know it went to the NH3? Well, if I look at it on the right-hand side, I can see that the NH3 became NH4. So I can see that the HCl gives up a hydrogen to the NH3, and the NH3 gains a hydrogen becoming NH4. So the HCl gives up the H+, becoming an acid, and the NH3 takes in the H+ and becomes a base. Now, if I want to take this one step farther, because, okay, that was really easy, but how else can I figure it out? Well, also look at the Cl. What's the Cl missing? Well, you can see that the Cl is missing a hydrogen. So therefore, the HCl must have given up that hydrogen and formed something else. So I can see that the Cl lost a hydrogen, and by losing the hydrogen, it was an acid. Okay, so HCl is the acid, NH3 is the base. It takes in the H+, base. Here's another example. Now, again, if I look at this, if I look at this hydrogen first, well, what am I looking for on the right-hand side? I'm looking for one of two things when I look over here. If NaOH lost a hydrogen, I should see NaO somewhere on the right-hand side, but I don't see NaO on the right-hand side. So clearly, that's not right. So this hydrogen must stay put. Well, let's look at this guy. If this is going to happen, this H is going to come over here. Well, I have an H, I have an OH. What's the H and the OH going to do? Well, the H and the OH are going to form water right here, leaving the Na to bond with the F. And I can see that if I look at the F and then I look at the F, I can see that the F lost a hydrogen. So if the F lost a hydrogen, that means HF must be my acid and NaOH must be my base. Now, the other thing you want to look for, and there's some example problems later in this that you can look at. The other thing you want to look for in reactions of acids and bases are strong acids and strong bases. Now, I hate to tell you, and I've been really good all year, and I haven't made you memorize stuff, but this you have to memorize. There are 7 strong acids and 7 strong bases you must memorize. So, the 7 strong acids. When the 7 strong acids react, they always form water and a salt. Okay? So, it doesn't matter what they are. So it doesn't matter which acid and which base you combine, you will always get the exact same thing. So in those 7 strong acids and 7 strong bases, which you have to memorize, know that if you put the 2 of them together, you're going to get water and a salt. Circle this. It is going to be important. It will pop up on major assessments later. Okay, now when you do this, your pH should be about 7, regardless of how you started. Okay, so when you combine the 2 together, you're going to get a neutral solution. Now, the other thing you want to think about when you're doing this, a different way to look at the reaction is keep in mind that the HCl acids are always thought of as H+, and bases are always thought of as OH-. Well, if you take H+ and you combine it with OH-, you get water. Okay, so keep those things in mind as you're doing this too. So you take a strong acid, which is considered H+, and you take a strong base, which is considered OH-, and you get them together and you get water. But if nothing else, if you look at this, if you ignore the fact that this is an acid and a base reacting, this also is a double replacement reaction. The H switches and combines with the OH minus, the Na goes with the Cl, and boom, you have a double replacement reaction. So if nothing else, you can always look at acid-base reactions as double replacement reactions. If you think about it like that, you'll never get it wrong.